Hello everyone, my name is Saqib and I am back again with a very interesting topic which is firmware reversing. So yesterday we learned about some hardware hacking and today we are going to learn about firmware reversing. What is firmware and how we can perform reverse engineering on that. This is something that we are going to cover today. So before begin, start the lab. It will take around 3 to 5 minutes to load, and meanwhile we can read the text. We have some theory part which is important because the practical part is based on the understanding of the theory. So let's begin our task. We can now learn more about the mysterious device found in Santa's workshop. This is something that we learned. Elf Forensic MacBlue has successfully been able to find the device ID. Now that we have hardware device ID, we need to help Elf MaxKiddy reverse the encrypted firmware and find interesting endpoints for IoT exploitation. This is the topic for the future. The learning objectives that we will be covering in this video are: what is firmware and how we can perform reverse engineering, the techniques for extracting code from the firmware, extracting hidden keys from an encrypted firmware, and modifying and rebuilding a firmware. Now, the question is, what is firmware and how we can perform reverse engineering? Now, if we look around in our home or in our office, we may find a couple of embedded devices. For example, cameras, switches, routers. I have a camera over here, and it is an embedded device that has a firmware in it, which is a predefined software, or we call it firmware, that has its own set of instructions that enables it to communicate with the software running on it, right? The firmware provides low-level control for the designer or the developer to make changes to the root cause. So how we can perform reverse engineering and what is reverse engineering? Reverse engineering is working your way back from through the code to figure out how it was built and what it does. Firmware reverse engineering is extracting the original code from the firmware binary. The software running in this hardware is a binary that we need to extract and then reverse engineer to obtain the code and understand what it does, what are the intentions, and maybe we can find some malicious or unintended functionality like undesired network communication calls. Firmware reversing is usually done for security reasons, to ensure the safe usage of the device that may have critical vulnerabilities leading to possible exploitation or the data leakage. And the important example could be: consider a smartwatch whose firmware is programmed to send all incoming messages or the emails to a specific IP address without any indication to the user. This is an important example. This is why firmware reversing is important for security reasons. So there are a couple of steps steps to perform reversing of firmware. Number one, we have to obtain that firmware. Either we can obtain from the hardware itself or the vendor website, or maybe we can also find the older version from somewhere. Maybe it is available on the website, or there are a lot of websites that keep the older versions of the data. So the first step is to obtain the firmware from the vendor's website or extract from the device. The second step would be to usually this is the binary file. We have to analyze to figure out what is its type. The third step is to identify if it is encrypted or not. If it is encrypted, then it may be challenging for us to analyze. This is something that we will learn today. To analyze, as it usually needs a tricky workaround, such as reversing previously unencrypted releases of the firmware or perform hardware attacks like side channel attacks to fetch encrypted keys. So what we need to do is, if we have the encrypted firmware, we need to find unencrypted version over the internet to extract the keys so that we can decrypt the encrypted version of that. Once the encrypted firmware is decrypted, we can perform various techniques and use tools to perform reverse engineering based on the type. Okay, So these are a couple of steps to perform reversing. There are two types of firmware analysis. As in case of malware analysis, similarly, we can also in the same case we will have to perform static analysis and dynamic analysis. As the name suggests, static analysis is a process of analysis where we extract sensitive information from the binary without executing. And for the dynamic analysis, we have to this process involves running the firmware code on actual device and observe its behavior through emulation or hardware software being or through debugging. And one of the significant advantages of dynamic analysis is to analyze unintended network communication for identifying data leakage. So for the static analysis, for this particular task, we will only be doing static analysis. This is important. And the tools that we are going to cover are Binwalk. This is an important firmware extraction tool that extracts code snippets inside the binary by searching for signatures against many standard binary file formats like zip, exe, elf, etc. And the second tool that we are going to cover is FMK, the firmware mod kit. This is also a very important tool. FMK is widely used for firmware reverse engineering, and it extracts the firmware using binwalk and outputs a directory with the firmware file system. This is important. We take the binary, we use this particular tool to extract, and it will give us the output would be the file system of the firmware, the decrypted file system of the firmware. Once the code is extracted, the developer can modify desired files and repack the binary files using a single command. This is also an important tool because it allows us to modify the files that were extracted and repack them with a single command. This is also important. And this is the third tool that we can also use, but this is something that we will not be using today. Okay, so enough of the theory. Let's start the practical work. So before starting, start the lab as we have done already. If there is a prompt for the password, we will use this particular password as an admin password to use. Okay, so if we look at the root directory and let list down all the directories or the files, we find three particular files. One is bin folder, three folders. One is bin folder. This folder contains the encrypted binary that at the end we need to extract that. Bin unsigned is another folder that contains unsigned binary or the previous version of the firmware. And firmware toolkit, this is a tool that we will be using. Okay, we have done a dir to list all the directories. The bin folder contains the firmware binary, we have covered that, while the firmware file contains this. So we will be using primary two particular tools. These are the two tools that we will be doing today. Okay, so the first step, so we will be performing 5 steps to complete our task. Task number 1, step number 1, verify encryption. How we can verify that our file is encrypted? Well, one of the reasons can be that when we analyze the file, we can look at the entropy to see the randomness in it. So we will use this particular command to find out the if the file is actual encrypted or not. In the bin directory, go to the bin directory, and there's a binary, and we will use binwalk with e to check the entropy. And let's find out if the entropy is very high, just like in this case. This indicates that the file is probably encrypted and has high randomness, and this is one of the key indicators. Okay, so we have confirmed that this particular file is indeed encrypted. Our second step, finding unencrypted old version. One of the ways we can look at is search over the internet to find the older versions. maybe the site contains the older version, or there are many sites which contains the older version of the website, and we can search through them to find the softwares of the older version. Since the latest version is encrypted, MaxKD found an older version of the same firmware. The version is located in the bin unsigned folder. Why was she looking for an older version? Because she wants to, like, this is a very important question to understand. Because she wants to find encrypted keys within that unencrypted uh, firmware, so that she may use to decrypt the original firmware and reverse engineer that. Our main objective is to decrypt the original firmware, but we can use the unsigned binary to obtain the secret keys. So let's move on to the unsigned folder, and let's see what's in it. It has a firmware that is unsigned. Okay, so our task would be to extract the sensitive keys from this particular file. Okay, so how we can do that? Okay, she extracted the firmware by issuing the following command. So we will be using fmk tool, and its command is extract firmware, and it will give us a folder name fmk that contains the file system of this particular um, firmware. Okay, it is asking for the password, and as I have mentioned already, we will be using the password that was mentioned in the task above. Okay, so what firmware can be found in this particular folder? Okay, let's find out what's in it. So we have the folder, and it contains all the binaries and all the files in it, which is very interesting. How we can find a particular private key or the public key within this these all the folders? This is our next step. So we have extracted the folder. Now our third step is to finding encrypted keys. How we can find encrypted keys? Well, the original firmware is GPG protected. GPG, if you look at the documentation, GPG is GNU privacy guide, which is used to encrypt or decrypt our data or the files. Okay, so we can read out over here how it is used. So, which means that we need to find a public key, a private key, and a paraphrase to decrypt the original signed binary. These are the three things that we need to find within these folders. We know that the unencrypted firmware is extracted successfully and stored is in FMK folder. The easiest way to find keys is by using grep. We can use Linux command line. One of the ways can be that we scroll through all the folders and the files, open them and search through them. And the other way can be using grep. And with grep, we will use the I flag for to make it case unsensitive, and with the R to look for to recursively search through all the folders and the subfolders. So we can use the keyword key, and what it will do is it will search for all the files that contains the letter key in it. So let's see, it will take some time. So if we look at the output, we are seeing all the instances of keyword, and great. So we have found a folder that contains the public key, and of- in the same folder we have the private key. Again, that's great. So we have found public key and the private key exactly like as shown over here. So our next step, we can also use this we can use this to read. Let's let, let- okay. Let me open the private key to just have a look at what's in it. So what I'll use is I'll use cat function to go into that particular folder. Sorry, and I'll use this command to, and what it will do is it will open all the private key and the public key. Excellent. So we have private key and the public key. So the question is, can we search through this particular folder to find paraphrase? So if I paraphrase, and excellent. So we have found the paraphrase, which is an important password. So what I'm going to do is I'm going to copy this, and it's one of the answers. So what is the paraphrase value? We have found the answer. We have yet to find the flag. Okay, so enter. We have found the right answer. Next step. Okay, so next step. What would be the next step? Bingo, we have the public key and the private key, but what about the paraphrase? This is something we have already done. Excellent. So MaxKiddy has finally located the public and private key in the paraphrase as well. Now we have come to the fourth step, which is decrypting the encrypted firmware. This is the our main objective. We have to decrypt that and find some endpoints. Now that we have the keys, let's import them using the following command. Okay, let's use the following command to import import the keys that we have found. First, we will import the private key. It will prompt for the password, and we have to enter the paraphrase that we have found, which is okay. So we have imported the secret key, private key. Now it's time to import private public key. Excellent. So we have imported both. Now our next step would be to we can list the secret keys. Now we can use GPG to list all the available secret keys, and excellent, we have secret keys available. Now once the keys are imported, MaxKDD decrypts the firmware using the GPG command. Again, change the directory to by entering the command. Okay, we have to go back to the bin directory. You know why? Because it contains the encrypted firmware. So we have encrypted firmware. Now we are going to use GPG to because GPG contains the private and the public key and the paraphrase, and we can use that to decrypt this encrypted firmware. So simple, just run this command, enter, and it will ask for the paraphrase. So use the paraphrase that we found earlier, and guess what we will get in the folder. So we have a file. This particular encrypted firmware has been decrypted using the private and the public key and the paraphrase. Excellent. So far so good. So we have left with just one step, which is step number 5, reversing the original firmware key. Just like we used this particular command to extract the unsigned unencrypted firmware, we will use again this particular tool to reverse the firmware in encrypted firmware. So what would be the expected result? The expected result would be the FMK folder that contains all the code, all the important files of the firmware. If we do ls, we can see a folder name FMK. Excellent. So we have successfully reversed an encrypted firmware. Excellent. So let's move on, and we are almost at the end. MaxKD has successfully been able to reverse the complete firmware and extracted essential files. What files? This is important. She will use, and these are the files that she will use for IoT exploitation next to. She has used the keys from the older version to decrypt the latest version of the same firmware. This is something very interesting. The camera folder, okay, if we go into the FMK folder, in that, if we go into the roots file system folder and list down, we found a folder named camera. This is something that will contain the all necessary files that we'll be using in the next task. Excellent. So we have found the flag. Open the flag, and we have found the answer. Excellent. So we are left with one question. After reversing the encrypted firmware, can you find the build number of root fs? Okay, so there is a hint as well. So we can use to find all the hidden files within the folders and the subfolders. Let's check out. Okay. Well, here I can find the version of the root fs built. Excellent. So we have found the answer as well. Build of enter. Yes, we have the right answer, and there are a lot of interesting rooms you can try out. So I hope you that's it. So I hope you learned something new here, and you found this task interesting and easy. See you in the next task, because next task is going to be interesting. Thank you so much.